Welcome to this Python tutorial on geocoding. My name is Ujjwal Gandhi from spatialthoughts.com, and today I want to talk to you about how to geocode addresses using GeoPy and GeoPandas. I'll be teaching you how to take a bunch of addresses in a CSV file or an Excel spreadsheet and use a web-based service to turn these into coordinates. That way you can use them for mapping or any spatial analysis. I'll also be teaching you some techniques of data cleaning. Real-world data is often messy and not ideal for geocoding, so we'll do some pre-processing to clean up our data that is suitable for geocoding. Once we get this geocoded, we'll also learn how to fix missing or wrong geocoded results, and then finally we'll display them on a map and download them as a shapefile. I'll be going through a notebook step by step and walking you through the process. The link to the notebook that we are covering is given in the video description. So with that, let's get started. Here we are using the Google Colab environment. Colab is a free cloud-hosted notebook environment where you can run a Python code without really installing anything on your local machine. You just need to sign into your Google account and you're ready to go. The notebook here gives the description of the problem. We are taking some data, some open data from New York City. It's a spreadsheet containing addresses of hurricane shelters. Let me show you what the source data looks like. Here is our source spreadsheet. We have a header row and a title row, and then we have some headers. And this essentially contains all the hurricane shelters in the New York City. So in case of there's a hurricane evacuation, you might want to reach this. And this data is best displayed on a map, so you can find your nearest shelter, or you can find out where there might be need for another shelter and so on. So if you want to use this system for geospatial analysis, you need to know where they are in the real world. So we have the address of that zip code, the state, etc., but we don't have the coordinates. So we need to take these addresses and find out their coordinates. We have about 65 addresses here, and we'll use this in Python environment to read this data and geocode it. So let's get started. Here, we'll just run some cells to install the required packages in our Colab environment. Colab already comes pre-installed with a few packages that we need, such as GeoPy, but we'll need to install GeoPandas and OpenPyXL and LeafMap, which is a library for visualization. So we just run this. I'm using this cell magic capture, which essentially doesn't display any output. So there are a lot of output being displayed. I don't like to see that when I'm just doing this, so it just keeps your environment clean. So the cell is run, it's ready to go, and now we can import all the packages. So we're going to use pandas to read the Excel file, GeoPandas to turn this into a geospatial data set. We'll use LeafMap for displaying data on a map, and we're going to use GeoPy for geocoding. Specifically, we're going to use the nominative geocoder, which is a free OpenStreetMap-based geocoder. The good thing about GeoPy is once you learn how to do this with nominative, it supports a variety of services such as Google here and other things. So the API remains the same. You just change the geocoder name and you can use those services. And finally, we'll be zipping the results, or we'll just use the zip file module. We're going to create a data folder and an output folder. The data folder where we'll have all our input data that we'll download and keep. Output is where we'll write all the output. This is running the cell that is downloading this data from a GitHub repository. You could also upload your data to the Colab environment. Come here and you can just upload data and use it that way. But we just have this data. So you can see the data is right here. The Hurricane Evacuation Centers.xlsx file is there. And now we can start our process. So the first step will be to read this data. So we'll use pandas. We just need to construct a path to this data set first. So we know that the file name is this, and the Excel file path is in the data folder. So this is the path. So let's just display this path once so you know what this looks like. Right, so we have data/Hurricane Evacuation Center. I generally recommend always using os.path.join. So you get the correct separator based on which operating system you're running it on. And now we can just use the pandas function, pd.readExcel, to read this file. Okay. And we'll get this address TF. Let's see what this looks like. Right, so we know that the first row of this Excel file is the title row. The data actually starts from the second row. So again, we get this messy data where we have this first title, but then there are unknown columns, and the first row is actually the column names. Pandas has this extra option when you read the file where you can skip some rows so that you know where the data starts from. So I'm going to use the skip rows parameter, and you can take a list of row numbers starting from 0 to skip. This is skip row 0. And if we skip the first title row, then we now get the clean data where we have the correct column names and the addresses here. Okay, so this is what our data looks like, about 64 addresses that we need to geocode. Okay. First step, we need to do some cleaning. If I take this address and try to geocode it, it sometimes fails because the nominative geocoder that we are using expects the street numbers that are here to be ordinal numbers. So instead of having 7002 4th Avenue, it expects it to be 7002 4th Avenue. And this is how we commonly speak the street names. But our data set doesn't have that. It just has the regular numbers. So we need to turn these numbers into ordinal numbers. So 36 will become 36th Street. 1 street will become 1st Street. 2 Avenue will become 2nd Avenue, and so on. So this is a kind of a good data cleaning problem, and I'll teach you how to do this in a data frame environment in a correct manner. So to do this, we'll have to replace our data and create a new column. So I'm going to go backwards. So I'm going to just say, I need a new column in my address data frame called fixed address or address fixed. How do we add a new column in Pandas? Where we'll take our data frame and we apply a function. So apply allows you to write a function that goes through each row or column and works with it. This is the preferred method of processing data in a data frame environment rather than just doing iteration or for loops. So we'll say we'll apply the function. Let's just say we'll call this function update address. And since we want to add a new column, that is, we're going to apply it row by row, and that is axis 1. So now, if you do this correctly, if you write this function correctly, it's going to take each row, read the data, and update each address. Okay. So let's define this function now. We don't have this function defined. And each time the function is called, it will be called with the row values. So all the values in a single row. So we'll just say our old address will be row of address, right? So it'll be these values. So we read this value, and now we want to update it with the ordinal numbers. Here we want to use regular expressions to be able to replace the pattern of the address with the correct number. So the pattern of the address here, this is United States, and the pattern of the addresses that are in the United States is the street number, so the house number or the parcel number, followed by the street name. So here the address starts with the street number, followed by the street name. So we're going to define a pattern like this. We'll say our pattern looks like some numbers followed by some text and followed by street, avenue, boulevard, drive, right? So we want to find a pattern where it is some number, space, street, avenue, boulevard, or drive. And so we want to extract this part, 25 drive, 7 avenue, and so on. Okay. So this pattern will extract this. Once we extract the pattern, we're going to extract the number of the street and then replace that with the ordinal value of that number. Okay. So we'll use the re.sub function. This is the regular expression package that comes built in with Python, and we're going to substitute this. So this function takes the pattern, the replacement function. So we'll just say what replacement we want and what value we want to replace. So we just want to replace this old address. For every row, we'll take the old address, find the pattern, and replace. Now this replace, if it was a static value, we could do this right here, but this also, we need to be dynamic. Depending on the pattern, we want to extract the parts of the pattern and replace it. So we'll also can use a function here. So I'm going to write a function ordinal here. And this will be my result. So I need one more function now called make ordinal, which takes a regular expression match and processes this. So this is what our function looks like. I'm just copy pasting this code. I'll just walk you through this. This takes the match. Here, our regular expression has two groups. So if you learn about regular expressions, once you match a pattern, you can surround each pattern with this brackets, and anything within the bracket, whatever match is the group. So you have one group and the second group. So we're going to take the match of group one, which is the number that comes right before these words. So it match street, avenue, boulevard, drive. So whatever number comes just before that, we're going to take that. And this is a bit of code to just replace 1 with first, 2 with second, 11th, and so on. Right? And we're going to return that ordinal number plus suffix, which will create the ordinal number. And then the remaining part, match.group2, which is whatever remains afterwards. So it was street, boulevard, avenue, and so on. Okay. So this one is complete now. Let's run this and see if our code works. So here it says none. Well, this is a common error. We compute the result, but we forgot to return the result. So I'm just going to return this. All right, so I think this works now. So you can see this address, 25 Drive became 25th Drive, 7th Avenue became 7th Avenue, and so on. And so this is showing you how to kind of apply some processing technique to clean up your data. And you'll often encounter this kind of problems in your data. So you can kind of get inspiration from this example on how to properly clean up using the pandas functions that are fast and also will make your data cleaning process much simpler. Okay, so we have our address. Before geocoding, we need geocoder typically takes a single string of address and returns the coordinates. So we need to create a string containing the full address. So that will typically be, this is the street address. So the number, the street, then we need a city name. So here we have a city, but again, this column actually, though it says city, is actually a neighborhood. So we actually going to use NYC, New York City, as the city name, and the state is New York. And we can also add the zip code to it. And that will form a complete address string that will be sent to the geocoder. So let's create a new column. I'm going to create a new column and we'll name this full address. And we'll take our, we'll create a string out of different columns. So we can just use the pandas syntax to get the column names and add together. So we'll take our address, df, address fixed. This is the fixed address column that we just created. We'll add a comma to it. Once we have the address, we need the city name. That will just be a static string NYC. Okay. If you had a column which contained actual city names, you can use that. Then we need the state. So we'll just do address df of state. Another comma. And then finally, we have the zip code. And the zip code is actually a number, so we'll convert it to a string. So this is a function called s type. Say whatever number is that, convert to string. Okay. And it should work. Let's see. So now we have this full address here. So you can see the address looks like this: 147-26, 25th Drive, NYC, NY 11354. Okay. So you need to get this address in a form that is recognized by the geocoder. A simple way to test if this address is geocodable is you can just copy this address, go to openstreetmap.org. This is the main map for the OpenStreetMap project, and you can just search. This map uses the same geocoder as the nominated service. So you can see this one was geocoded correctly. And you can kind of play around with this to see how nominate and geocoder understand this. And the same applies to other services. If you're trying to use Google Maps, go to Google Maps and type in your address. If that address is recognized by the service, then you can have that address string sent to the geocoder. Okay, so we are ready to geocode now, and we're going to use the nominatim service. The nominatim is a free geocoding service, so you don't need an API key or a user account. All it needs is a user agent. This has to be just a unique string that identifies you. So just use your name or some unique ID here that will identify you. We also have this extra parameter timeout. Sometimes, since it's a free open server, sometimes it's a bit flaky. So you send a service and it just times out. So it just adds an extra timeout saying that wait for 10 seconds for a response. We're going to use the nominative service and get the geocoder. This service also puts a restriction saying that you can send only one request per second. And most services will put such restriction. This is called rate limiting. So depending on the service you're using, you need to adhere to this rate limit. If we don't put a rate limit and just apply this function on a data frame, Python can actually send this request very, very fast, and you'll see a lot of failures. So the GeoPy also gives us a rate limiter where we can take our geocoder and apply the rate limiter. So here we are using the rate limiter that is provided by GeoPy, which takes the geocoder and adds a delay. So we'll say it'll add 1 second delay between each request. And now we have a geocoding function which takes an address and returns the coordinates. Okay, let's just test this geocoder. Sometimes before you try and go and apply this to pandas, it's good to just test it locally and see how it looks. So I'm going to just take one address here. So let's just take this first address string and we'll say geocode this address. Let's see what we get back. Okay, so you can see we get a location object, which is now get the full address as it exists in the database, along with X, Y, and Z coordinates. So we know our geocoder function is working with the string that we gave. So now all that is left to do is apply this function on a data frame to add a new column with that. Okay, so let's try that. So I'm going to add a new column called location, and we'll take our whole data frame and apply this. We have to just select, we can also select just one column, and we'll say just apply this function on this column and geocode it. Okay, this will work. Here, another technique that you should be aware of is we have about 65 addresses, so it's going to take 65 seconds at least to geocode this. What if you had 1,000 addresses? It's going to take a while for the process to finish. It'll be nice to see a progress bar and see how far it has been done. So if you ever need a progress bar in a Jupyter environment, the library to use is called TQDM. And this again comes pre-installed in a Jupyter environment. So I'm going to just use TQDM and we'll just use the notebook progress bar. TQDM has a lot of functions to track progress. Since we are applying a function on pandas, we'll just use the pandas function. So we'll just say TQDM dot pandas. And what this does is it gives you this new function. Instead of apply, we'll use the progress apply function. Okay, so this will now send this geocode function through this TQDM library, which is going to track progress of how far the library has come through. Okay. And once it's done, we're going to open up the library, the data set. So let's start this process. And you can see this nice progress bar. It's going to track progress as it's going through each row, geocoding it. The function also will work with addresses where it cannot geocode, it'll return null. So if it is successful in geocoding, it's going to return a location object, which we are saving in this location column. And if it doesn't work, it's going to return a null value. And we'll need to deal with that as well. Okay, so the geocoder finally finished after taking a minute or so. And we see that we have the results here. So you can see we have our original data frame and a new location column. And as we saw earlier, it's an object which contains multiple values. We just need the X and Y coordinate, the latitude and longitude out of it. So we'll try to just extract that and save it to their own columns. So we want to take the address df and create a new column, latitude. So latitude is the Y coordinate, but we can access the latitude value from the location object directly. And to do this, we'll need to look at the address column. So the location column, which contains the location object, and we need to again apply a function that will just read that and extract the latitude values. We can write a function, but instead of writing a new function and using it here, we can just write a function inline. And inline functions in Python can be written using the lambda keyword. So just say lambda. The input to this function will be the location column, since we are selecting only the location column. And what we want to return is just location.latitude. So this is what the function will do. We'll also add a condition if location. So if location is not null, you return the loc.latitude. If it's null, just return null. So this is just to kind of inline function that reads the location objects and extract the value of latitude from that. And I'm going to copy paste this and just do the same for longitude. We'll change this to longitude. So get a data frame after this. So now we have two columns, which is the latitude and longitude that we've extracted out of our geocoding itself. And this is what we wanted. We started with an address, fixed the address, applied a geocoding function that got us this location object, and we extracted lat long out of it. So we're almost done. Let's just clean up our data frame so we can save it nicely. One more thing before we proceed. We don't know how many of this geocoding results fail. So it'll be nice to just check and see if we can do something about it. So to check if any of this are failed, we can just say, look at the address df and show me all the rows where address df of location is null. So pandas has a lot of functions to deal with null values. So you can see there's one row, one address which failed. Right? So it says there's null value. And this address could not be geocoded. So we can choose to either say, let's just drop this. If you want to drop this, you can just select all the values where address df of location is not null. So if we just use this negative operator, you'll select all the rows which are not null, copy this to a new variable, and you set you can have the remaining rows which you can proceed. But what if you want to use this row and not miss out on this data? Well, you have an option. One option is go back and try to see if something could be done to fix this. Sometimes the addresses are just not present in the database or are in a format that the service doesn't understand. You may want to use another service. So many of the services are available that require you to sign up for an API key, pay some money in many cases. And once you set up, you can try a different service and see if that gives you a better result. Sometimes it's also just say, okay, I don't know this address, but I can go and find it on a map. So you can go and say, oh, I'll just manually find this. And wherever I find it, I'll get the coordinates manually. So if you want to update this coordinates manually, you can also do this. So we have this address df. You see the index 54 row is missing the address. So we're just going to update it manually. So I'm going to just say, locate this row. So we use log function and we say row with the value 54, index row 54, get the latitude and longitude columns. And so I just want to show what this is. So this is just going to give you a series which says these are the two null values, and it will just assign the correct value to this. And the correct value, which I just discovered by browsing the map and using the best estimate to say this location has this coordinate, right? And we just go and assign this. So this will now assign this. And if I just run this again, you'll say that this one now has latitude and longitude, which we updated. So now we have lat long for all the addresses that we wanted to do, and we can now clean up our data frame. So we'll select a subset of it. So I'm going to select the name, address, lat, and long. That's all I need. The name of the place, the full address that we geocoded, lat long. The rest, everything is not really required for my output. And we'll also rename some columns. So this row will just say, take the EC name, make it name, full address, make it address, and so on. And let's just look at our finding. data frame. Nice. So this is the result of our work. We started with some data, and now we have this nice and clean data frame, which has got track long. We could end here. You can just save it as an Excel file and do something with it, import it into QGIS or something. But let's just turn it into a spatial data. Let's just turn it into a GeoPandas geodata frame. So we can use this in some analysis and also convert to any format that we want and directly get a spatial data format out of this. So we need to create a geometry column. So GeoPandas has this function points from XY, which takes X and Y column. So we're going to take our address df dot longitude, which is the X value, and address df dot latitude, which is the Y value. And this generates a geometry column. As you will see, if you run this, you'll get a point object for each of the rows. And we'll just assign this as a geometry value. And we now use gpd.geodataFrame, which takes a data frame. We'll take our address df, takes CRS, and this coordinates our lat long. So APSG 4326 is the CRS, and a geometry column. And out comes a geodata frame. We'll save this as address GDF. All right, so now we have a geodata frame with a geometry column. We can actually visualize this data. So I'm going to use leaf map to visualize at this point on the map. We're going to create a leaf map, and we can specify 800 width, height 500. Okay. And if you just try to display this map, it'll be a blank map of this dimension. We can take the geodata frame, and GeoPandas is this really nice explore function, which can create a foliar map. So we'll just say explore this map on this map. And you can see there are some points here. Yeah, so these are the geocoded points. And you can, as you hover over it, you'll see the information about each point. So this is done, but again, let's make this a little better. We'll also want to zoom into this particular region. So we have the leaf map has this function zoom to GDF, which just takes the bounds of a GDF and sets the bounds of the leaf map. So it is pressed to this geodata frame. So now when I run this, it'll be centered. The map will be centered on this. Cool. We'll also add some styling parameters. So I'm going to add a different marker to this. We'll just add a hurricane icon since these are hurricane shelters. So let's just run this. And you can see these are the icons now, which display this icon as a hurricane icon. So looks good. So this is useful just to check our data. Maybe you want to, show this on a map. This is a good way to do this. But again, most of you might want to just download this data as a shapefile or GeoPackage or a GeoJSON, etc. So we have a geodata frame. We can just save it to an output file. Here, I'm just going to show you how to save it to a shapefile. So we'll define the name of the shapefile, and we'll just use this function, take the data frame to file, and run this. And this is going to take this file and save it to the output folder. Okay, so you can see this contains all the different files that are part of the shapefile format. So shapefile is not a single file. It contains a whole bunch of sidecar files that together form the data set. So we got an output and we're going to zip them together. So it's easy for us to download this. And this is some code which I traced through this 4 files. These are the 4 files that are needed at the minimum to form a shapefile. It's going to take those 4 files and create a zip file. And now we have a zip file here which contains this. I'm going to download this here. So the result got downloaded to my computer, and now I can visualize this in a GIS software. Here I am. Here I've opened QGIS, which is running on my computer, and this is the zip file I downloaded. I can just drag and drop the zip file, and you can see I have the point locations along with the attribute table here. So now I have a spatial data set, which I have in a GIS environment, which I can use this along with the other data sets. So this video covered the workflow of geocoding using GeoPy. Hope you learned some best practices and also some data cleaning technique. Do try this out on your own data set and let me know how it goes. Thank you.